Hi viewers, you are welcome to today's video. In today's video, we are going to be talking about some symbols used in electrical circuit diagrams. When drawing an electrical circuit diagram, there are different symbols we use to represent different instruments in an electrical circuit. And most times, if you don't know these instruments or the symbols that represent each instrument, and then you are asked to translate a diagram into a connection, an electrical connection, it becomes very difficult. So in today's video, that's why we want to focus on the symbols that represent different instruments in different electrical circuit diagram. And we shall also be showing you some of the electrical equipments that these symbols represent. So if you are new to our channel, please make sure you subscribe, then you share and give this video a thumb up. Okay, so let's go. So we have different electrical symbols or different symbols that are used to represent different components in an electrical system. They are so much you cannot finish exhausting them, because every day there is a particular component that's coming out, and of course there is also a conventional method of representing it. So here we have 10 different components. Number one, we have the cell. Then we have a battery of cells. A cell is a source of energy in the circuit. Okay, a cell is where you generate energy that flows into the circuit, or you can say a source of electricity in the circuit. And then a cell and battery, the difference between cell and battery is that cell is one unit, but once you have more than one cell in a system, then you say that you have a battery of cells. So you can say this symbol that represents more than one cell. Okay, so once it's more than one cell, then you have a battery. You call it a battery of cells. So there are two different types of cell. We have the wet cell and we have the dry cell. So here is an example of a battery. Okay, that's a collection of two or more cells. Okay, here is a battery. Of course, this is a dry cell. This is a dry cell. Then the second thing we have in here is the ammeter. The ammeter, you can see the circuit symbol, the ammeter. So ammeter is used to represent is an instrument that you use to measure current that's flowing in the circuit. All right. So here and here is the instrument called ammeter. You can see it. That is labeled as A. So once you see this kind of instrument, then you present it when you want to represent this instrument in a circuit diagram, then you write the circuit like this, then you write A inside. That's ammeter. So the third thing we have here, the fourth thing we have here is the voltmeter. So voltmeter is used to measure the potential difference between the two terminals of a connection, or you can say you use it to measure the voltage in the circuit. And this is the cell symbol or the circuit symbol for voltmeter. And here we have this instrument here is the voltmeter. So you can see it written here V, which is the voltmeter. So this particular instrument is what we present on this board here, but with this symbol. So anytime you see this symbol, you know that it is talking about connecting to this instrument, which is the voltmeter. Okay, so the fifth thing we have here is the galvanometer. You can see the difference between a galvanometer, voltmeter, and ammeter. Okay, so once you see a circle like this with an arrow pointing towards this direction, then you have a galvanometer. And here we have a galvanometer. Okay, here we have a galvanometer. So you can see it. This is, once you see this kind of instrument and it's written here G, then then you know that it is a galvanometer. A galvanometer also is used to measure current flowing through the circuit. But this time, unlike ammeter that measures large currents, galvanometer are used to measure very little currents. Okay, the galvanometer is very, very sensitive, so you measure very small currents in the circuit. So The sixth one we have here is key. Key. What is the function of a key in a circuit? We use key to switch on the circuit and to switch off the circuit. Switching on the circuit means to allow the electric to complete the circuit so that current can flow in the circuit. So by switching off, it means to disconnect the circuit so that current will not flow in the circuit. And this is symbol for representing key. Another, in modern days language, we can represent key. We can say that that a key is a switch. If you come to house wiring, what represents key in house wiring is a switch. Okay, you can switch something on, you can switch it off. So that's what we call a key. So for in academics, the key we usually use is this type of key. So this is a key. Okay, this is a key. So this particular instrument is what is represented as this. So this is an open key. So this is a key. This is what you use to close the key, and when you remove it, you open the key. Okay, so this is key. So the seventh thing we have here is what we call the fixed resistor. The fixed resistor. What resistor does in the circuit is it opposes the flow of electric current. So, and what the work of resistor in the circuit is to reduce the amount of current that is flowing into a particular component. Because some components may need large current to flow into them, some other components may need just small current to flow into them. So when you meet an instrument in the circuit that needs small current to flow into them, then you use a resistor to reduce the amount of current flowing into that particular component. Okay, and here we have a 2 ohm resistor. A 2 ohm resistor. Okay, this is not only the form in which resistors appear, but this is also a resistor. This is an example of a resistor, a fixed resistor. That's a standard resistor. Okay, so the standard resistors in circuit can either have this shape or it can have this symbol. Okay, so the next thing here is we have the variable resistor. So you can see the symbol of the variable resistor. Anytime you see this resistor symbol with the arrow pointing this way, then you know you are dealing with a variable resistor. So variable resistors are also called rheostats. They are also called rheostats. And here is an example of a variable resistor. Okay, this particular instrument is variable resistor. So you can see it's rheostat. Here is a variable resistor. Okay, so in case you have not seen it before, this is a variable resistor. And this particular instrument is what is represented by this diagram in a circuit. Okay, so the ninth stuff we have here is the lamp. The lamp is your normal bulb. Okay, lamp can appear in different sizes, in different designs. So your normal light bulb in your house is a lamp, or normal energy bulb, whatever bulb you have is a lamp. It's red and lamp. Even these small bulbs, these small tiny bulbs, as long as it gives you light, okay, then we call it a lamp. Okay, so the next thing we have here is we have capacitor. Okay, capacitor is used to store electric charges in a system, in an electrical system. We use capacitors to store electrical charges. Okay, so in electricity, there are common terms that we usually use in electricity, and those common terms is what we call the conductors and the insulators. You can say in insulator, you can call them non-conductors. So conductors are substances that allow the passage of electricity through them. Any material that my electricity can pass through it, then you say it's a conductor. And we have several examples of a conductor, but all the examples of conductor are grouped into metals. All metals conduct electricity. They allow electricity to pass through them. Okay, so you see they are conductors. Metals are conductors. They are not salts, solution of salts. Of salts, when they are in molten form or in solution form, then they conduct electricity. So they are also conductors. And then inorganic acids or mineral acids, they also conduct electricity. So those are conductors. Then insulators or non-conductors are materials or substances that do not allow the passage of electricity through them. Okay, so we have examples of insulators or semiconductors. We have woods, we have materials like rubbers, then we have materials like ebonite, materials like pure water. Once the water is pure, it doesn't conduct electricity. Okay, but of course, most of the time we deal with pure water, with water that are not pure. So any water that is not pure, of course, will conduct electricity because it contains some dissolved minerals, which apparently is, or some dissolved salt, which enable it to conduct. Okay, but once it's pure water, it doesn't conduct electricity. Okay, so then we have organic acids. Okay, organic acid solutions doesn't conduct electricity. So if you're new to the channel, please consider subscribing and share this video, so and also on the notification button so you can get notification each time we post a content of this magnitude. Okay, so see you in our next video. Bye for now.